Okay, looking at this from the standpoint of thermodynamics, this is your pressure enthalpy curve. So if I look at this big system and look at and try to describe it in terms of the pressure enthalpy curve, then I want to start with the easiest thing. And the easiest thing to me is this cooling. So if I'm cooling, it means I've taken this energy out of the room. But this thermodynamic curve, this pressure enthalpy relationship that we know, is relative to the fluid inside the system, right? So relative to the fluid inside the system, I am taking in heat in order to cool. I am taking in heat. So where do I take in heat on this curve is what I should be thinking about. Where do I take in this heat into my my working fluid? Well, I take in heat here into my working fluid. I went from a lower enthalpy to a higher enthalpy. I took in some heat. So let me kind of color code this. If I were to draw like, here's the cooling, then I would say the cooling happens down here on the curve. So that means that I'm probably going to have the pressure going in is going to be the same as the pressure coming out. And the temperature going in is going to be lower than the temperature going out, and the enthalpy at the beginning of this, when you take on all of this, is going to be lower than the enthalpy when you take on all of that heat. So I would look at cooling first. And now I would also look at heating. So in the heating condition, we are putting some energy into the room, into the supply air. We're putting energy in, but that means for the system, what that means is that we lost some energy from the refrigerant. So again, this is from the standpoint of the refrigerant right here. And from the standpoint of the refrigerant, I have lost some energy. So it's important to note, it's important to note there that I am working at the top of this curve. So I'm going to have I'm going to go from a higher enthalpy to a lower enthalpy, right? From a higher enthalpy to a lower enthalpy. And I'll just try to draw that for you. From a high enthalpy to a lower enthalpy here, and pressure hasn't changed. And then now we get into where the loads are. So the problem is that this is not like that typical heat pump system, in that it has this building zone where there are some loads happening. So these happy people sitting in here actually are giving off some heat. And they are giving off, they are both giving off heat and they're giving off humidity, because these are people, right? So here's a happy person in here giving off heat and giving off humidity. And if they are giving off this heat and humidity, that means that it's a load. It is something that the system has to deal with, this load. And the heat that they are giving off is going to go into the system related to m dot delta H. That is of sensible, which means you can measure it in temperature. And the latent heat is the heat that doesn't change temperature according to the mass flow of the system and the change of energy of the system, the change of enthalpy in the system because of the humidity change. So what you don't know, or what we maybe don't remember, is that people give off measurable temperature change and a change in humidity, but both temperature and humidity affect enthalpy. So the effect of these latent loads from these basically hot and steamy people is going to be dependent on how much flow is flowing through the system, how much they can accept this change of energy. So that's a load that goes into the system. And that's kind of new. And if we were to do a first law energy analysis, these are significant. And our first law energy analysis will say, it will say, I have some ventilation air coming in at a flow rate m dot. It has this amount of enthalpy HA. It has the same, and then it has, it's going to gain some enthalpy. The fluid is going to gain some enthalpy according to the flow rate of the fluid as it sucks in energy from the room. Then it's going to lose some enthalpy in relation to the fluid flow as it gives some energy to the room. Then it is going to gain some enthalpy because of sensible heat, hot people. It's going to gain some energy because of latent heat, moist people. And then it's going to dissipate some of that energy by wasting it in exhaust. And that would be our first law energy balance that we can describe on a pH curve.